Good morning, everybody. Today we will discuss the ortho-para ratio of the aromatic electrophilic substitution reaction. Normally, in a mono-substituted aromatic ring having an ortho-para directing group, we are expecting the ortho-para ratio as 2:1. This is because for every benzene ring which have a ortho-para directing group, that is an activating group, will produce 2:1. The product ortho-para ratio is 2:1 since we have two ortho positions and one para position. For example, in toluene, we know that the toluene, the substituent is methyl group and it is an electron donating group and which is act as a activating group and it donate its electron to the benzene. So that's why benzene ring is electron rich. So the electrophile can attack both the ortho positions and one para position. So our expected outcome of the product, that means the ratio of the ortho para is 2:1. And here also in this example also that expectation is valid. In the orthonitrotoluene, the percentage is 63% since we have two ortho position, and paranitrotoluene is 34% since we have only one para position. But the ratio, that means the ortho-para ratio, depend upon many factors. First one is the steric hindrance and polar effect of the substrate and solvent effect, temperature, etc. So we are mainly focusing the steric effect and polar effect of the substrate. So first of all, consider the example as we discussed earlier in the toluene. If you are adding the nitrating mixture, that is HNO3 and H2SO4, naturally we will get the nitrotoluene. So here in this example we will get the para product is 61%, whereas the ortho product is only 39%. This is because we know that the CH3, it is little bit bulky than that of hydrogen. So it produces a steric hindrance in the ortho position. See here I have shown the ortho position, and in the ortho position it acquires some steric hindrance. That's why since the ortho product is only 39%, since we have two ortho position, even then we have only limited product in the ortho position is available, only 39%. Whereas in the para position there is no steric hindrance, so that's why the ratio, that's why the para product will produce 61%. See here in the tertiary substituted benzene, if we are adding the same nitrating mixture to the starting material, we will get two product, ortho and para, but the ortho product is only 60% available due to the steric hindrance, and the para product is 84%. So as the steric hindrance of the substituent which is already present in the benzene ring increases, the ortho product, the percentage of the ortho product decreases. So the ortho para ratio decreases. So the size of the alkyl substance which is already present in the benzene ring increases. The attack at the ortho position become more difficult. So that's why the percentage of ortho isomer in the mixture of the product decreases. Now we are moving into the another concept, that is the intensity effect of the substrate. See, this is an halogenated halobenzene. So the ash color board represents the halogen group, and normally we are expecting two product since the halogen group is an orthopara directing and it is considered to be an electron donating group because it has a property of the back donation due to the availability of the lone pair of electron present in the atom. So that's why it is considered as an orthopara directing group. So now normally we will get two product, ortho product and para product. Then see the table. First one is the fluorine. So in the case of fluorobenzene, we are expecting the experimental result shows that ortho product is 13% and meta product is only 1 and para it is 86%. And whereas in the case of the chlorine, the ortho product is 30%, meta 1% and para 69%. In bromobenzene, ortho 43%, meta 1%, para 56%. In the iodobenzene, ortho 45%, meta 1% and para 54%. So, in this table clearly shows that as we move from the top to bottom in the group of the 17th group, we can see that the size of the atom normally increases. So the electronegativity normally decreases from top to bottom and the donating capacity of the halogen increases from top to bottom. So as we move from top to bottom, the electron due to the as the electron donating capacity increases, so the ratio percentage of the ortho product is normally increases. See here in the fluorine, it is a small atom, there is no steric hindrance. Even then the ortho product is only 13% because fluorine is electron withdrawing in nature and it have only less capacity for the back donation. And in the case of chlorine, the size is little bit higher than that of fluorine and the electronegativity is lesser than fluorine. So it have the more donating capacity than when compared to the fluorine. So that's why the ortho product is 30%. Then coming to the bromine, the size is little bit higher than that of the chlorine and electron donating capacity is little bit higher than that of the chlorine. That's why the percentage is 43%. And in this table, iodine shows the more electron donating capacity. That's why the ortho product in the case of iodobenzene is 45%. So the iodobenzene give more ortho product and inductive effect predominate over the steric effect in governing the ortho-para ratio. We know that the iodine is bigger in size when compared to the fluorine, chlorine, bromine. But even then the ortho product is more in iodobenzene since it have the more inductive effect and donating capacity than that of the any other halogen group. That's why in this case inductive effect predominate over the steric hindrance. That's why ortho-para ratio is higher than that of the other halogen group. So in conclusion, the ortho-para ratio means it is depend upon the steric hindrance of the starting material and the inductive effect of the substrate. As the steric hindrance increases, the ortho product decreases, and as the inductive effect increases, the ortho product increases. Now we are moving into the next topic, that is ipso attack. So ipso means it is a Latin word, its meaning is itself. So any aromatic ring in which one of the position which is already occupied by a non-hydrogen substituent and that position is known as ipso position, and ipso means it is itself. And if any attack on this position is called ipso attack, and the substituent which is already present in the benzene ring is replaced by the other substituent, and this type of the reaction is known as ipso substitution reaction. See, in this example, the silyl group which stabilizes, it is acting as a strongly electron donating group, and it reaches the benzene ring. And here in the first example we have two substituents. One is the silyl group, the second one is the OH group. So when we compare these two groups, silyl group is more activating group, so that's why it have the more influence on the benzene ring. So in the electrophilic attack, we have to consider the electrophile will attack on that position, the ipso position of the silyl group. So I have shown by the red arrow mark, this is the position of the attack of the electrophile. Then the benzene ring undergo the resonating structures, and after that the electrophile, here the electrophile is the H plus, because we are doing the we are using the acid, so the silyl group is replaced by the hydrogen. So in this method we can easily remove the silyl group by hydrogen. So the ipso attack, it is the reverse of the Friedel-Crafts reaction. Whereas in the second one, there is only one function group here, so that is the silyl group. So the normally electrophile will attack. Here also we are using the acid. So the electrophile will attack in this ipso position, and after the resonating structure, the silyl group is replaced by the hydrogen. So again we are doing the reverse of the Friedel-Crafts reaction. So we can easily substitute one of the function group by the hydrogen. Okay, then the benzene ring is generated. And the speciality of this reaction is that the silyl group, while we are attacking the electrophile in the silyl position, a carbocation is generated in the hydrogen atom, the carbon atom beta position. The cation is generated in the beta position is highly stable. So that's why silyl attack is more possible in ipso attack. I hope that you understood the concept. Thank you.